Hey everyone, and welcome to the second part of my video series on traffic avoidance in general aviation. If you've missed out on the first part and you want to know why I find electronic traffic avoidance systems are a great thing to have and are important also in the general aviation segment, it's linked here in the top right corner for you. As promised, I'll be talking a bit about electronic platforms and devices which will put traffic on your flight instruments or on your tablet in the cockpit in the second part here, so stay tuned for that. Now, first of all, a little disclaimer. While I researched the internet a lot to find information about the different electronic traffic systems, I'm actually not an expert on all of that. I'm just a pilot trying to help others with the knowledge I was able to build on this subject. I don't work for any company who builds or sells these devices, nor am I being sponsored or anything like that. Now, this video might actually be a bit technical and rather boring if you're just interested in entertaining aviation stuff. I'm presently stuck here at home due to the coronavirus, so you'll have to wait for a little while for some real flying action. Now, what can you expect in this video here? I'll first give you a little repetition on how our radar systems work, what kind of information a transponder provides to air traffic control, but also to others in the vicinity. I'll tell you what an active traffic system is and what it does. We'll be looking at ADS-B and then at FLARM in more detail. We'll try to put all we've learned together to create an overview on the compatibility of these systems, meaning which kind of receiver and display device will be able to display which source of signal. Finally, I wanted to give an outlook what we might or might not expect in the future on the different topics. I'll give you a little timeline here on the left side, so if you only want to find out more on one topic, you can skip the rest of it. Now let's get right into it by looking at some basics. Traditionally, the position of an airplane has always been determined through radar systems. The most basic radar system is primary radar, and that's also called primary surveillance radar. Primary radar means that a radar transmitter emits radio waves which will be reflected by any solid object. The lateral position of an aircraft can be determined like this without having any onboard equipment in the plane. If you, for example, happen to have a complete electrical failure, or you're thinking you're being smart by switching off your transponder when flying somewhere where you actually shouldn't be flying, ATC can mostly still obtain your position through a primary radar. After World War II, when civil aviation volume grew, secondary surveillance radar was introduced. Now, with secondary surveillance radar, transponders started to send replies to the ground station's interrogations, first using only the classical 4-digit code that we all know. That was only mode A. Thereafter mode C was invented, where the replies also contained the aircraft's altitude. In the meantime, the use of mode S transponders has been mandated for a while. These kinds of transponders squid information, they broadcast information in regular intervals and hereby reduce the number of interrogations that are required to identify and follow an aircraft on the controller's radar scope. They have also solved a couple of issues that had evolved in the even denser airspace environment that we're seeing today. There are actually two types of mode S transponders, those that just serve the basic so-called elementary surveillance functionalities. You could maybe call it or think of it as sort of as basic mode S transponders. And then there's those who also downlink additional information, that's for example your aircraft speed or the selected altitude that you have selected in your autopilot window, for example. This will then be called enhanced surveillance. Now, it's important to note or to know that mode S isn't yet the same thing as ADS-B, not even with the enhanced surveillance functionality yet. Now, before we jump into ADS-B, I'll talk about the first of our traffic systems that we're going to be looking at today, which are the active traffic systems, sometimes also just referred to as TAS, which just means traffic avoidance system. Now, these are definitely the most expensive ones to get other airplanes displayed in your cockpit. They work by interrogating other transponders in your vicinity, which will then respond mostly in the same way as they respond to a radar interrogation. Then using the time of flight of the signal and the return signal and the altitude of the other airplane which is contained in the return signal, the TAS will display the traffic on your screen. You can think of that basically as sort of a mini radar system that you have with you in your airplane. Now these systems can cost more than 10,000 euros. They're usually rather heavy. They are deployed mainly in high performance single aircraft, in faucet twins or even in turboprops. Now many people mistake these systems for TCAS used in the airliners. While TAS and TCAS work in a similar manner, they're still not the same. TCAS systems are more advanced. They will issue resolution advisories, while a normal TAS system doesn't. So with a normal traffic avoidance system, you're still required to maneuver visually to avoid the traffic, just like with all the other systems that I'll be talking about in the next minutes. Now, what's the big deal with that ADS-B thing then? ADS-B stands for Automatic Dependent Surveillance Broadcast. Simply said, ADS-B just adds your exact position by connecting, for example, a certified GPS to an ADS-B transponder to all the data we are squiding that we're broadcasting already. Therefore, ADS-B transponders sometimes have an ES in their names, which just stands for Extended Squidder. All of this is usually referred to as ADS-B out. Now, if you think of it, ADS-B will allow to get rid of the classic ground stations interrogate and transponder replies game that we've been seen before. All that's required now is a receiver on ground and no huge radar antenna anymore. ADS-B has a couple of huge advantages for ATC, but also for us as pilots. Radar installations are getting cheaper, controllers get an almost real-time traffic picture, also in remote areas through satellite reception. The entire traffic flow gets more efficient as the ATC's radar screens are being updated more frequently. And in the end, we as pilots are getting optimized routings and all that kind of stuff. It's for all these advantages that in the US having ADS-B out is now mandatory for almost all airspace users in a variety of airspace categories. Also in the EU we have a mandate for aircraft with a maximum takeoff weight of more than 5.7 tons by the 7th of June this year, which is 2020. But in the meantime, there's also a nice choice of affordable ADS-B out transponders for smaller GA aircraft, with more and more owners upgrading to ADS-B out there as well. By now, all this ADS-B stuff maybe doesn't sound like much of a benefit for us as pilots. However, we can add a benefit for ourselves by getting a receiver to get the almost exact position of other airspace users equipped with ADS-B out transponders in our vicinity, which obviously makes it very interesting for our traffic avoidance systems. All this is then usually referred to as ADS-B in. Now in the United States, for example, there's a network that rebroadcasts all the ADS-B traffic and even weather to pilots through ADS-B towers, which can then be displayed in your cockpit or on a tablet device. Here in Europe, we unfortunately don't have a network like this, but it's still possible to receive ADS-B out signals directly from other aircraft within your vicinity and the reception range. To do so, we have the choice between various little portable ADS-B receivers, but also through transponders who will not only do the ADS-B out component, but will also be able to receive ADS-B signals and send them to the avionics or a tablet again. A small problem is that almost all of these devices have been developed for the US market, where a certain level of reliability of the ADS-B out signal is mandatory. This level is called Source Integrity Level, or just SIL. Now, while the FAA requires a level of at least SIL 3, while SIL 1 is acceptable in some exceptional cases, EASA has decided that they are happy with any kind of ADS-B out signal, also SIL 0 from non-certified GPS sources. So the problem with ADS-B in transponders designed mainly for the US market is that it will reject signals with SIL 0, which means that the bigger part of the smaller GA aircraft here in Europe will not be displayed. So if you want to buy a ADS-B in and out transponder, make sure to get one that will accept SIL 0 targets as well, or simply buy one of the portable receivers. By the way, ADS-B receivers are also the main source for commercial aircraft tracking services like Flight Radar 24, for example. If you maybe think about using ADS-B out, but you're worried about your privacy and you don't want your plane or your flight to show up on these sites, you can block your aircraft directly there with these services. Now we've talked a lot about ADS-B, it's time to look at the traffic avoidance system that's more commonly used here in Europe, called FLARM. FLARM stands for Flight Alarm. It's a Swiss brand that started to develop their products to avoid collisions between gliders in the first place. By now they say they have equipped, I think, more than 40,000 manned planes, but also drones with their system. And they offer by far the most well-known platform for traffic avoidance here in Europe. The way FLARM works is really comparable to ADS-B. It also sends position and altitude, however on another frequency, and receives the signals from other FLARM devices and also often ADS-B out transponders to generate traffic warnings. A huge difference is that the transmitting power of FLARM is, I think, quite a bit smaller than ADS-B. Remember that FLARM was first developed for the application in gliders. This means usually others will see you later and vice versa, which means that depending on the aircraft and the speed you're flying, everybody will have a little less time to spot the target and avoid it accordingly. That's actually why a fixed installation with externally mounted antennas will be the way to go when you're flying in a motorized aircraft with high cruising speeds, to be seen by others timely, as the external mounted antennas will obviously lead to a better signal range. I can talk from my own experience. In my aero club we have 3 Tecnam P2008s with a FLARM system, with only the little interior antennas that are mounted to the side windows in the cabin. With this method, the system is not really reliable, if not even rubbish. Sometimes you receive signals while sometimes you don't. We have the same base unit with 2 external antennas mounted to the belly and the top of the club's Cessna 172s, and that's actually a big difference. The way the whole system works is a lot more useful and a lot more reliable. For transmitting a signal from inside a light carbon glider, a portable FLARM unit might be perfectly fine. But if you're sitting inside a heavier piston-powered aircraft with a huge engine block up front and the avionics stack, and maybe even have a metal wing or a metal body, or both of that, the signal strength of the FLARM is maybe just too weak to deliver useful results. The main reason why FLARM is so popular here in Europe is because of its relatively cheap price point. Mobile devices are available for about 2,000 euros. Fixed installations will be obviously a bit more expensive due to the installation cost. It's important also to note that almost all FLARM devices that are being sold today also receive ADS-B data actually. So maybe at this point you're hoping for an advice which platform is best, or simply which device you should buy. Well, obviously, unfortunately, I can't give you this kind of advice. I don't know which kind of flying you're doing, which plane you're flying in, what speed you're traveling at, what your budget is looking like, and all that kind of stuff. I'd say the disappointing message here is that you could spend 10,000s of euros for a traffic avoidance system and still find that it won't be covering all traffic, and it will still have its downsides. What I want to try to do now is give you a hand in making the best choice that works well for your individual situation. To be able to do so, it's important to understand how all of these systems work and how they interact with each other, all these platforms, and obviously to know their limitations. What you need to understand, I think, is that just because you're seeing a traffic target on your screen doesn't necessarily mean that the other guy is able to see you electronically. Transponders and traffic avoidance systems can do two things. They can make others in your vicinity visible to you, or make yourself visible to others electronically. Some do both, some do only one of the two. You might think that an ADS-B out transponder doesn't offer any benefit for you, because you won't be able to see others with the device alone. What it does is making you visible to almost anybody who has a traffic avoidance system on board himself, so it will offer benefit for you in the end as well. On the other hand, for example, there's a popular small little portable device out there which will be able to send all FLARM and ADS-B targets into your navigation app like SkyDemon or ForFlight. It costs only 500 euros plus some license fee for the FLARM licensing. That sounds awesome. Now, what you might not realize in the first moment is that this device alone won't broadcast your position in any way to others. So if we all had this unit, we would all receive, but nobody would send. So in the end, we all see nothing, even if we have Mod S transponders on board. I know this all sounds simple, and you maybe think that all of that is very obvious, but with all the different units on the market, it's quite easy to lose track on what product does what. To facilitate your search, I created a PDF file to give an overview on which kind of traffic a type or a unit will display to you and how it will make yourself visible to others. It's of course free, and it's again not sponsored. I'll link the document below this video for you to download. If you are an expert and you find some information is missing or maybe even wrong, please let me know. If you actually decide to upgrade a plane in your flying club, or you have a flight school and you want to upgrade your fleet there, or you own a plane yourself, make sure to talk to an avionic expert who will then also be able to look at the aircraft individually, check how it can integrate into the existing avionics. What I've heard, in some cases it might actually be better to use a dedicated traffic display instead of an existing MFD or a navigator or an iPad display, to also show traffic which is presented with range information only. Now, as I already said, there's not a one-fits-all solution in regards to electronic traffic aids when you're a pilot here in Europe. I'm still renting myself in the US. I'm flying Cessna 172s, mostly in California, and with the ADS-B traffic and weather broadcast they're having there, it's really a no-brainer to buy a little portable receiver for less than 500 bucks, and you will be having free in-flight weather and almost all the traffic around you in ForFlight on your iPad. Now, of course, it would be awesome to have all of that here in Europe as well. But there are a couple of test stations in the UK transmitting precipitation radar images. Garmin has installed, I think, a system like this in Friedrichshafen at Aero last year in Germany. There's also one of these systems in Denmark, but for what I know, that's it. I don't think we'll be seeing a network like the one in the US in the next couple of years here in Europe, because I guess nobody will be willing to pay for that. There's a discussion on whether we have to expect a mandate for ADS-B out transponders for all GA aircraft here in the EASA countries. Maybe or maybe not, we all have to buy new transponders again one day, but I guess this won't be for another couple of years. What might be more realistic than a European ADS-B FIS network is a provider that receives and rebroadcasts weather and traffic data through a mobile or satellite internet connection, I think. I'm not sure, maybe you've followed the news on projects like Starlink, which is one of Elon Musk's companies, who plans to put, I think, 40,000 mini satellites into space to provide a broadband internet connection in every single corner of this planet by the end of this decade, actually. I think this is a possible infrastructure the entire aviation and general aviation industry could benefit from, and get more connected with each other, also when thinking of collision avoidance, which could be cheaper than the ADS-B FIS-TIS network in the US. After I've talked about all these electronic platforms who will help you in spotting other airplanes in your vicinity to avoid a possible collision, I want to make it absolutely clear that see and avoid is our number one means and our number one technique that we have to avoid a conflict in the air. FLARM and all the other systems that I talked about are supposed to assist you with your see and avoid. I think they can be a great help, but please remember to keep your eyes outside the cockpit whenever you're flying VFR. Now I've been talking for quite a while now. I know this video was very specific and only interesting maybe for a few people out there. I hope you still learned something today. I'm desperately hoping that I'll be able to go flying soon once the coronavirus has been brought back under control and things are reopening. So I'll be able to share with you some videos with some real flying action instead of just this maybe rather boring stuff here. Please leave a comment on what you think of this video series, if you found it helpful or not. Maybe give me a thumbs up and subscribe to the channel. I can tell you creating a video like this is actually quite a lot of work, and I'd appreciate your support there. For now, that's it. Please be safe out there, stay healthy, and as always, many happy landings.